Today we are going to use the division properties of exponents to simplify expressions. So let's take a look at what that property is in this first problem. So here we've got 3 to the 5th on top of a fraction. And so what we'll do to figure out the property is write this in an expanded form. So 3 to the 5th means that I'm going to be multiplying 5 3's together on top of the fraction. Down below I have 3 to the 2nd, so I'm going to be multiplying 2 3's on the bottom of the fraction. And what I'll do from there is cancel out the common factors. So when I cancel things out, they make the number 1. And I'll do that again on this problem. These cancel out and make the number 1. Well, 1 times 1 just makes 1. So what I'm left with is 3 3's on top of the fraction. So I could rewrite that as 3 to the 3rd power. And then down below, 1 times 1 is just 1. So what the rule is we can just cancel out common factors on the bottom of the fraction with common factors on top. So if there's 2 3's on the bottom, it's going to cancel out 2 3's on top, leaving me with the difference left over. And so that's the basic rule we're going to do, is we're going to end up subtracting the exponents. But when we do that, we're going to think about where they're left. So again, what I'm going to be doing here is I've got 2 3's here. I'm going to cancel out those 2 3's by taking away those 2 3's. And here I'm going to take away 2 3's left as well. And that's how I'm left with 3 3's on the top of the fraction. Now if the numbers are small enough like this, we'll go ahead and multiply that out, which would just make 27 as our answer. Well, we'll use that same rule with this next problem here. So what we're going to do is look at how many A's are left. So if we wrote it out again, this would be A, and then 2 C's. 1, 2 C's. And then down below we have 3 A's and we have 4 C's. So again, our rule is that we're going to take the difference of the exponents and see where they're left in the fraction for the ones with the common base. So the common base is A. So I'm taking away 3 A's from the bottom and 3 A's from the top, which leaves me with 1 A. So basically what I'm doing is I'm taking these 3 A's away and taking those same 3 A's away from the top, leaving me with 1 A left on top of the fraction. That's what I have right here, same thing. But for the C's, it's a little different. So the C values, we take away 2 from the top and take away 2 from the bottom. But look where those C's are left. They're left on the bottom because we have more C's on the bottom of the fraction. That's a little different than the book's going to teach you. The book's going to teach you just to subtract the exponents, and if you end up with negatives, then take their reciprocal. Here, we're bypassing that step, and so we're just thinking about where those C's are left. So there's less C's on top, so I'm taking those away and taking those same C's away from the bottom, leaving me with 2 C's on the bottom of the fraction, which is what we had in the picture we have down here. And so my final answer then is A to the 1st power, or just A on top, and C squared on the bottom. Well, let's take a look at the next problem, and this one has just more terms. And so what we're going to do here is think about the x's. Now here's a problem where I don't really want to write out 8 x's, and I don't want to write out 9 x's, so let's go ahead and just use our rule. Picture those 8 x's on top, just like we had 4 a's on top up here. Well, let's take out those 8 x's from the top, take away 8 x's from the bottom. That leaves us with 1x on the bottom of the fraction. So let's go ahead and rewrite our fraction here, and we'll stick that x in there. So we've got 1x left on the bottom. Now let's take a look at our y's. So our y values, we've got 1y down here, which we're going to take out away from the 3 y's on top. Now I can only take 1 y from the top because I have 1 y on the bottom. Just like here, I could only take out 2 C's from the top and bottom because I only had 2 on top. So what that leaves me with is 2 y's on top of the fraction. So let's go ahead and write that in our answer here. 2 y's on top of the fraction. Now let's take a look at those z's. Well, we only have the z's on the bottom of the fraction. There are no z's here, so that's what we have to write out in our answer. So those 2 z's on the bottom of the fraction. And that would be our answer. It's all simplified for us. Well, the next problem has something a little different. Here we have some coefficients. So when we have coefficients, kind of like on these problems, we treated the A's and the C's separately. We're going to do the same thing with this problem. We're going to treat this as two separate problems. Now, I like to do that because it's a little different. A lot of people think, oh, I'm supposed to subtract 3 from 15, but that's not the case. See, really what I need to do is reduce this fraction. So think of it this way. Think of it as 15 thirds times by x to the fourth over x, two separate problems. And so when I do that, I'm going to reduce the fraction here. Take out the common factor. Take out the 3 from both the top and the bottom of the fraction. So let's go ahead and rewrite in our new problem what we have left over. 15 divided by 3 makes 5. 3 divided by 3 just makes 1. So I've reduced the fraction. Now let's see how many x's are left. Well, this 1x will cancel out one of the x's up on top, leaving me with 3 x's on top. And so that's what I would write down. I would have 5x to the third power over 1, or just 5x to the third power. And that would be our answer. Now, same sort of thing here. Again, you're treating this as two separate problems. Difference here is we don't have a big factor like we did on the last one to reduce it down to 1 in the denominator. So I'm going to just take out the common factor that we see. So I just rewrote this as two separate problems so you can see the difference between those two and how I'm going to do this. So I'm going to take out the common factor of 2 from the top and the bottom of the fraction. So let's see what's left over. I've got 14 divided by 2 just makes 7. 12 divided by 2 makes 6. Now I'm going to extend that fraction bar to leave room for the x's. Let's see how many are left. So here I have 5 x's on top. Picture those 5 x's. Well, those 5 x's are going to cancel out 5 x's from the bottom, leaving with how many x's? 7 minus 5 is 2. So I have 2 x's left on the bottom of that fraction. So I'm going to write down x to the second power. And there's our answer. 7 over 6x to the second. So I like to do that because it saves myself a step. So maybe the textbook might ask you to subtract the fractions, and you'd get x to the negative second on top, but then you'd have to take the reciprocal. So this method allows us just to initially get those x's where they're supposed to be in the fraction. So the next problem just has more parts to it. We've got coefficients, we've got x's, we've got y's, and z's. So I'm thinking of it as 4 separate problems that eventually I'm going to combine as one. So I got 10 over 15, and then x to the 9th over an x to the 3rd, and I have a y to the 2nd over a y to the 6th power, and then a z over a z. So we can go ahead and reduce this by taking out common factors. So here the common factor is 5. So once I reduce it, then I'm going to rewrite my answer in this new fraction that I wrote down below. So 10 divided by 5 makes 2. 15 divided by 5 makes 5. Now let's think about how many x's are left and where they are in the fraction. See, wherever there's more x's is where they're going to be. So there's more x's on top. So that means those 3 x's on the bottom are canceling out 3 x's on the top, leaving me only with 6 x's left on top of the fraction. And so that's what we'll write down. What's left over is 6 x's on top. Now again, the common mistake is people want to divide sometimes those exponents, but that's not what we do. We're just canceling out common factors. So same thing here. Canceling out 2 y's from the top, taking 2 y's from the bottom, but notice there's more y's on the bottom, so that's why we rewrite it, that y to the 4th, with those y's on the bottom of the fraction. That's where they're left, y to the 4th on the bottom. And how many z's are left? Well, this z will cancel out the other z. So 1z cancels out this 1z, and that just makes 1 over 1. Well, 1 times a number doesn't change it, so that's as far as we take the answer. And so there it would be. We can erase the part of that fraction bar and just circle the rest of the answer. So our answer would be 2x to the 6th over 5y to the 4th. The next part will have some powers raised to powers.